A radical equation is it's an equation which includes radical expressions. So in order to solve one of these, in order to solve a radical equation, we have to get rid of the radicals, right? You get rid of the radicals by raising them, by raising each side to the same power as the index. So for example, if you have the square root of x is equal to 5, let's say, you would raise both sides to the power of what? 2, right? Because the index is 2. If you have the fifth root of x is equal to 3, you would raise both sides to the power of what? 5, because that's the index for that problem, right? That's how you eliminate it, okay? Now, so if you have the square root of x, you raise it to the power of 2. What if it's written in fractional exponent form? So what if instead of the square root of x, the equation is given to you as x to the 1/2 equals 5, right? Well, now what you would have to do to get rid of that exponent of 1/2 is you have to raise this to the power of the reciprocal. So if it's 1/2, you raise it to the power of 2. All right? So here, if you have x to the power of 1/5 is equal to 3, you raise it to the power of what? 5/1, right? So you see how even it's written in different form, but they're the same equation, and I solve it the same way, all right? It's important when we're dealing with roots to always go back and check your solution to make sure that it works, because you might have ended up with an extraneous solution. When you square both sides, when you raise both sides to the power of 4 or whatever, you artificially may introduce solutions to a problem that normally would not have existed, right? So you then have to eliminate the ones that wouldn't have worked in the normal case. So you have to go back and check your answers. All right, so how do we go over some steps on solving these equations? First and foremost, you have to isolate the radical on one side of the equation, okay? Then you raise each side to a power equal to the radical, and then you solve the resulting polynomial equation. Do not forget to check your results. Okay, so let's start with our very first one. So first step is to isolate the radical. Well, here I've got a radical, -1 equals 5. How am I going to isolate that radical? Add 1 to both sides. So I get that the square root of y minus 1 is equal to 6. Now I raise this to the power of which is the same as the index, so power of 2, power of 2. So y minus 1 equals 36, and how much is y? 37, right? Because I add the 1. All right, so now let's check. Let's check to see if that answer works. In order to check, you have to plug it in back into the very original equation. So let's see, is the square root of 37 minus 1 the same as 5? So root 37 minus 1 is root 36, which is 6 minus 1. That is equal to 5. So yay, this answer works. So I do write y equals 37 on my answer line. Okay? If you got your solutions and you didn't check, and one of them had to be eliminated, but you missed that part and you wrote it on the answer line anyway, you can't get full credit for it, right? Because part of it is to eliminate answers that are not right, right? You can't just go giving, random solutions to a problem. Yes?
What if it's like not?
This next problem, what's the difference in there for that one? It's got 2 radicals. Now, the ideal situation, it's easiest, it's most practical if you have each of the radicals on one side of the equation, right? It is possible to solve if you have 2 radicals on one side, but it's a little bit more complicated. So put each radical on each side of the equation, right? Now, we're going to square both sides. Yes? Okay. Now, let's go slow here. On the left side, what am I going to end up with? Just x minus 12, because that square and the square root just cancel each other out. So I just end up with x minus 12. Now, the right side is a little bit of a different situation, because the right side, you've got two separate items that are being squared. So I have to do my a minus b squared business, right? So how do I do this? I square the first one, what does that give me? 4. I square the last one, what does that give me? Positive x. Now, what goes in the middle? 2 times negative root x times 2. So negative 4 root x. Okay? All right. Now, let's see what we're going to do here. Subtract x. Hey, look at that. Those x's totally go away. So now I have negative 12 equal to 4 minus 4 root x. What can I do now? Subtract 4. Negative 16 equals negative 4 root x. What can I do now? Divide by negative 4. So I get positive 4 equal to root x. What's x? X is 16. Okay, let's make sure that works. So let's check and see if it works. All right, is the square root of 16 minus 12 equal to 2 minus the square root of 16? Well, 16 minus 12 is what these days? It's 4. Square root of that is 2. Does that equal to 2 minus 4? No. So it's no solution. Right. It is a little bit of a disappointment, but hey, it's no solution. Huh?
You can just like hope, yeah.
You could hope. You could hope. There's always hope. Yeah, and you can.
We can think about no solution. There's gonna be more opportunities later in this chapter to have no solution.
Later in this chapter? Well, this is the last of the chapter, so on the test, yes. Okay, so just give me a ratio of how many they're all group tests, and it, like technically, because we're all in it together, and in spirit we're all together. So yeah. Okay. So there we go. So we're gonna subtract 1. 3n plus 2 to the power of 1 over 3 is equal to minus 1. What am I going to raise this
3
to the power of? 3. 3. All right. So look, the 1/3 and the 3 cancel out. So I have 3n plus 2 is equal to what? Negative 1. Subtracting the 2, I get 3n equals negative 3. And what is n equal to? Negative 1. So let's check, and then I'm going to tell you about what this means here.
You wouldn't raise everything to the power of 3 like you usually would? Because on the first step, you wouldn't raise everything to the power of 3?
I did here. I raised, well, first I isolated the radicals, subtracting 1. Then I raised everything to the power of 3. But see, this is it's a parenthesis here, right?
Oh, yeah.
So it's one entity. Okay, so let's check into the original equation. So is 3 times negative 1 plus 2 to the power of 1/3 plus 1 equal to 0? Well, here, right, parentheses, exponents, right, we're doing order of operations. Negative 3 plus 2 is negative 1 to the power of 1 over 3 plus 1. Is this equal to 0? What's negative 1 to the power of negative 1 to the power of 1/3?
1i.
Well, this is the cube root of minus 1, so it's how much? Cube root of minus 1? What's the cube root of minus 1? It is negative 1, right? So negative 1 plus 1 is equal to 0. So this does work. So why is the cube root of minus 1 equal to a negative 1? Exactly, because negative 1 multiplied by itself 3 times is negative 1, right? So if I have the cube root of negative 8, how much is that? Negative 2. Now, if I had the square root of negative 16, the square root of negative 16, that's no good, right? We get an imaginary number. But with the cube roots, what about the fifth root of minus 1? How much is that?
Yeah, if it's odd.
It's negative. If it's odd, I have no problems. Okay, the 87th root of negative 1 is what? Negative 1. So if it's odd, I have no problems. So listen, this brings us to an important point. Here, we were solving a square root, right? And you know that a square root or any type of even root, whether it's a square root, fourth root, sixth root, you can only have a 0 or a positive number as the radicand, right? An odd root, however, has no limitations. You can have anything inside an odd root, right? So it's not that important to check if you have an odd root, but you have to check your answers for an even root. Does that make sense? Okay. All right. Well, when we checked 16, 2 doesn't equal negative 2. Right? It doesn't, when you put it back in, it doesn't work. Okay, now let's do this one. We're going to isolate the root, the radical. So I have here 3 times 5y minus 1 to the third equal to 2. Now, divide by 3, divide by 3. So 5y minus 1 is equal to the power of 1/3 is equal to 2/3. Okay, now, raising this to the power of 3, raising this to the power of 3. On the left side, what happens? Cancel out. So I get 5y minus 1 equal to what? It's 2/3 to the power of 3. Now, here's the question. Who does that exponent of 3 belong to? Does it belong to the 2, the 3, or both? It belongs to both. So they each get cubed. So it's 8 over 27. Okay? Now, I'm going to add 1. I'm going to add 1. All right? So now watch how I do this. 5y equals 8 over 27 plus 1. Okay? Now, we're supposed to do a common denominator. Here's my shortcut, okay? When you have a fraction and a whole number, I do a loop. 27 times 1 is what? 27 plus 8, 35 over 27, the same fraction, all right? Now, what do? Divide by 5. Or multiply by 1/5. Good. Right? So I get y equals, we divide these, so it's 7 over 27. Okay, now, this was a cube root, all right? And like I said before, cube roots have no restrictions. You can put anything inside a cube root, so we know that this is going to work. The domain of cube roots is all reals. The domain of even roots is not all real, so we must always check to make sure our solutions work, okay? All right, now, what about, so those were the equations. Now, what about the inequalities? All right.
No. You should put these on the number line.
Okay, no, because it's an odd root. So the inequalities add one tiny little step. Right? Now, I need to solve an inequality, and you know with an inequality, somebody mentioned a number line. With an inequality, you don't get just one answer, you get a range of answers. So you want to make sure that in that range of answers, you don't include any numbers that make the radicand negative. Okay? So first we have to make sure that the radicand is positive or non-negative, then we have to solve the actual inequality. Right, so look. So first, if the index of the root is even, identify the values for which the radicand is non-negative. So that's what we're going to do first. First, we have to make sure the radicand is 0 or positive. Then solve the equation, and then we're going to test values. So look, I split my work area down the middle. Now, first, I want to make sure that whatever answer I get makes the radicand 0 or positive. So I take this, the stuff inside, and I say that has to be greater than or equal to 0. All right? So now I solve, just like we did in chapter 1. And I get that x is greater than or equal to 2. And I just let that hang out there for a little bit. Now I'm going to move on, and I'm going to solve the entire inequality. 3x minus 6 in the square root plus 4 is less than or equal to 7. I'm going to subtract 4, so I get root 3x minus 6 is less than or equal to what? 3. Square both sides. So I get 3x minus 6 less than or equal to 9. 3x less than or equal to 15. X is less than or equal to 5. Yes? Now, let's put these two on a number line and see what it looks like. On the first hand, in the red, I said that x must be greater than or equal to 2. So all of those numbers. Then in the blue, I said, wait a minute. No, x has to be less than or equal to 5. So now I need to take the region where the two of them coincide, and it's this region here, right? So I say 2 is less than or equal to x is less than or equal to 5. So my numbers have to be between 2 and 5. All right? Question. Okay, let's do another one then. Let's isolate the radical. What am I going to do? Subtract 1. Oh, sorry, before that. Right. Before that, let's just work with the radicand and make sure it's always greater than or equal to 0. Right. You always set it greater than or equal to 0, regardless of where the sign is pointing in the beginning. So x is greater than or equal to minus 1. Now for the whole root. For the whole inequality. So root 2x plus 2 is greater than or equal to 4. I square both sides, and 2x plus 2 is greater than or equal to what? 16. So 2x is greater than or equal to 8. Sorry, not 8. 14. And x is greater than or equal to 7. Okay? Now, let's graph this and see what that looks like. All right. On the one hand, I have a requirement for x to be greater than or equal to minus 1 at all times. Yes? On the other hand, I have a requirement for it to be greater than or equal to 7 at all times. Now, your final solution has to be those numbers which satisfy both of them, not just one, both of them at the same time. All right? So, for example, would 0 work for this? No. 6 wouldn't work either. Anything from 7 and above will work, right? So you say x is greater than or equal to 7, right? Only that region. Okay? So you have to take the one where a number can fall into both of the categories. Okay? Questions? All right. So what would have happened if the red one pointed to the left and the blue one pointed to the right? What would have happened then? If one went that way and one went that way, there will be no common region, so what would the solution be? No solution, right? Okay. You always have to, yeah, you always have to check on a number line. It's a helpful visual. All right. Here, let's do our radicand first. So 4x minus 4 greater than or equal to 0. And x is greater than or equal to 1. Oh, yes. Because no matter what this inequality is, right, regardless of what this is, the radicand can be 0 and it can be a positive number, right? I could have 0 in here, I can have a positive number in here. So no matter what, it's always greater than or equal to 0. Yeah.
But for the other one, we got -1.
Right. The final answer doesn't matter. What matters is that initially you set it to greater than or equal to 0. X might be -1, but when you plug x into the radicand, when you plug -1 into x, you get 2 times -1, which is -2, plus 2, you get 0. So that works. So it's not this, it's the final value when you plug it into the radicand. Okay. So, here, root 4x minus 4 minus 2 is less than 4. Whoa. So now, radical 4x minus 4 less than 6. We square both sides. 4x minus 4 is less than what? 36. So 4x is less than 40, right? And x is less than 10. All right, let's put it on a number line. On the one hand, I say that x is greater than or equal to 1. But here I say that x is less than or equal to 10, right? Look, that's an open circle. Okay? Now, this is the region that I want. So, 1 less than or equal to x, but less than 10.
It's not less than or equal to.
No, because you see the main inequality? It's just less than, not less than or equal to. So all of this is less than. So that's an open circle, but that's a closed circle. So 1 will work for this. 10 will not work for this, but 9 will work. All right? Okay.